This video is on solving systems of linear equations, word problems. So sporting goods store receives a shipment of 124 golf bags. The shipment includes two types of bags, full size and collapsible. The full size bags cost $38.50 each and the collapsible bags cost $22.50 each. The bill for the shipment is $3,430. How many of each type of bag are in the shipment? So the first step we need to do here is to actually define our variables. We have two different types of bags. So we have full size and collapsible. So I'm going to say that I'm going to use the letter F is full size and the letter C is for collapsible. The reason I want to use letters that represent the words I'm using here is so that when I solve for something, I don't have to think about, am I solving for the full size or collapsible if I'm just using X and Y. So I use F, so if I solve for F, I know that I'm finding full size. You can still use the letters X and Y as long as you know which is which. The next step is to write two equations. Because we have two different bags, we have two variables, we need to have two equations. One variable means you'll have one equation, two variables, you should have two equations. So we have 124 golf bags. Well, we know that the only two types of golf bags we can have are the full size and collapsible. So we can write that the full size, so F, plus C should equal to 124 golf bags. Then we're told how much each of them cost. We have $38.50 for the full size, $22.50 for the collapsible, and we know that the total amount of money is $3,430. That will help us to write our second equation. So we would have 38.5 F for the full size plus $22.50 each for the collapsible should equal to a total of $3,430. Next, we're going to choose our method for solving. You can use substitution, elimination, or graphing. Since we're doing this algebraically, I'm going to use either substitution or elimination. Your method for choosing is up to you. I am going to choose substitution for this method, for this problem. The reason I'm going to use substitution for this problem is because I can easily solve for one of the variables in the first equation and substitute it into my second one. So I will take my two equations. So I'm going to solve, so step 4 is solve. I'm going to have F plus C equals 124, 38.5 F plus 22.5 C is equal to 3,430. I'm going to take my first equation and solve it for one of the variables. It does not matter which. I will solve for C in this case. I'll put C is equal to 124 minus F. Now, because I'm using substitution, I'm going to take this expression that is equal to C and substitute it in for the other C in the problem. So now I will have 3850 F plus 2250 times 124 minus F is equal to 3,430. Now to simplify, to use the distributive property, we'll have $38.50 F plus 22.5 times 124 is 2,790. Then 2250 minus times negative F would be minus 22.5 F is equal to 3,430. So I'm going to combine my terms. I'm going to come over here. I'm going to combine my 38.5 F minus 22.5 F, and we'll get 16F plus 2,790 is equal to 3,430. Now I can solve for F by subtracting. We'll have 16F is equal to, so 3,430 minus 2,790 is 640. I can now solve for f by dividing by 16, and f will equal to 40. Now that I have f is equal to 40, I can take my 40 and plug it into one of my original equations. I will plug it into my top one because I can easily solve for c from there. So I'll take my first equation, f plus c equals 124. So my f is 40 plus c is equal to 124. So in order to solve, I just subtract the 40. So c will equal to 84. Now, our solution, we're going to write our solution. I don't want to necessarily write it as a coordinate because this is a word problem. I want to put it back into context. Our solution is that we have 40 full size and 84 collapsible bags. We could write this as a coordinate if we were graphing it and we knew which one represented our x-axis, which one represented our y-axis. But because we are writing it in word problems, we want to make sure we write our solution in context of the problem. And the question asked how many of each type of bag are in the shipment. We want to know the exact amount of what type we have. So we have 40 full size and 84 collapsible bags. And again, I used letters to represent that, so I knew what my 40 went with, and I knew what my 84 went with. If I had used X and Y, I would have had to have rethought about what was X and what was Y. Another problem, the beach resort is offering 2 weekend specials. One includes a 2-night stay and 3 meals at a cost of $195. The other includes a 3-night stay with 5 meals for a cost of $300. Find the cost of a 1-night stay and the cost per meal. So we need to define our variables. So we have 2-night stay and 3 meals, 3-night stay and 5 meals. So our variables that we're seeing here are the nights and the meals. So I'm going to use N is the night stay, and M is meals. Next, we're going to write our equations. The first equation we have is that a 2-night stay and 3 meals is $195. So we can say that 2 nights plus 3 meals is equal to $195. The other includes 3 nights with 5 meals, so plus 5 meals is equal to $300. So we want to find the cost of a 1-night stay and the cost per meal. So we want to solve this. So the method I'm going to use for solving here, since it's not going to be easy to solve for one of the variables, because I would have to divide by 2, or I'd have to divide by 3, or I'd have to divide by 5 on this one. So I'm going to use elimination for this instead. Now, neither one of the n's or the m's have the exact same number, but I can do easy multiplication here. I cannot make the 2 become a 3 or the 3 become a 5, so I will have to multiply both equations by a value. So I'm going to multiply to eliminate the n's. I will multiply the top by a 3 and the bottom by a 2 so that I have the same n value when I multiply. Now, because I'm going to have a positive and another positive, I have to make sure that one of my numbers I multiply by is a negative. Because remember, for elimination, you have to have the same number but opposite signs. So I'll end up with a negative 6 and a positive 6. So that will give me opposite signs. So when I distribute, we have to remember to distribute all the way to every part of the equation. Because if you don't, you're not manipulating the entire problem. So the top equation will become a negative 6n minus 9m is equal to negative 585. The bottom equation will become a positive 6n, a positive 10m equal to a positive 600. Now we can combine them, so we have a negative 6n and a positive 6n will become 0. Negative 9m and positive 10m is 1m equals negative 585 and 600 become a positive 15. M is equal to 15. Now that we have m equals 15, and we don't have to do anything else to solve for that, we can substitute this m equals 15 back into one of the original equations. I'll just plug it into my top one. So I have 2n plus 3 times our m value is 15 is equal to 195. So we'll have 2n plus 3 times 15 is 45 is equal to 195. Subtract the 45, so 2n will equal to a 150. Divide by 10, n will equal to 75. Now that we have both values, we can answer the question. Find the cost of a one-night stay and the cost per meal. So one night stay is $75. One night stay is $75, and one meal costs $15. And again, this is why we use variables that represent what we want, so that we don't have to rethink about which one is X, which one is Y. I chose to use elimination on this one again because it would have been a little bit more complicated to try and solve for a variable, because I would have had to have divided by 2. None of these are divisible by 2. Or I would have had to have divided by 3 to get m by itself, and I know 2 is not divisible by 3. Same thing on this bottom equation. If I had solved for n, I would have had to have divided by 3. 5 is not divisible by 3. Or if I solved for m, I would have had to have divided by 3 in the end, and I know that 3 is not divisible by 5. So that's why I chose to use elimination. On this next problem, this one just says that the sum of two numbers is 19 and their difference is 7. What are the two numbers? In this case, we don't have variables or words that represent the things that we want, so we can just use the letters X and Y. Because it's not like a night stay and a meal, these are just random words. So we're going to use that the first number is X and our second number is Y. So our first equation comes from the sum, which means addition, of two numbers is 19. So we have X plus Y has to equal to 19. And their difference, which is subtraction, so we would have X minus Y is equal to 7. What are the two numbers? So when we look at this problem, it's already in standard form, and if you look at the Y's, we have a positive Y and a negative Y. These will automatically eliminate each other. So we already have it in a form that will eliminate. We don't have to multiply, and we don't have to use substitution. So I'm going to use elimination on here because it's already set up that way. I'll combine these. X and X is 2X. We have a Y minus Y is 0 equals 19 and 7 is 26. So if we solve for X, we get X equals 13. Now that we have the X value, we can plug it into either one of these equations. So I'll plug it into my first one. It would be 13 plus Y equals 19. So Y, if I subtract the 13, Y is equal to 6. And we can check that. 13 plus 6 is 19, and 13 minus 6 is 7. So our first number, the two numbers, because it just asks what are the two numbers, the two numbers are 13 and 6. So again, the reason I did elimination on this one instead of substitution is because of the way we were able to write the equations. automatically set up elimination where we didn't have to do any extra math.